All right, I did a cable winder. Kind of interesting. It could have been pretty simple, but I wanted to be able to wind this thing in either direction. I wanted to be able to tell it how far to go in either direction, and get some feedback from that. So what I have in my build, and I'll show you kind of the code and how it goes. The build has two buttons over here. There's a button that counts up, so I can count number of inches by button presses. If you look down in my variables right there, as I press this thing, it counts up. The other button, if I went too far, will subtract that value in the opposite direction. I've got a potentiometer over here with a little dial on it. That controls my motor going either forward in direction, so I can wind going down or up the given distance that my count is at. There's an integrated encoder built into this 269 motor that counts, and I've determined that every 100 counts on this was equivalent to an inch. So I've set this to be, the count is an inch, so this would roll 3 inches in whatever direction I turn my potentiometer. I created a variable speed potentiometer. The further I turn it, the faster it goes, or I can slow it down going the other way using the slope of the graph of potentiometer versus the motor speed. And then in order to get that thing to reset back to 0, I created tension from both directions so that the rubber band would pull this knob back to center. After you rotated it one direction, it would pull it back to center. And then, like in his, I wanted a range that was 0. I didn't want it to have to land perfectly on 0, so I have a range of quite a bit distance wedge cut out of the middle of that. So if we look at the code on how that was done, we have a couple variables. One is the count, so the button press, and the other is the motor speed. And that was put in there just so that we could start to see the relationship. The motor speed, it was important to see kind of what was happening as that motor speed was getting or using the equation with the given count. So, the other part of this thing is I want feedback, because once you start pushing buttons here, positive and negative buttons, hard to remember how many you did. So I created a loop, a second task that's running parallel with the first, that blinks the LED, the number of counts you're on. So it's blinking 5 times, cycling through, and then there's a pause, and then it blinks 5 times. So I know that's dealing with 5 inches. If I back that up to, it will blink 1, 2, 3 times. Okay, I could add one, and it would go back to 4 times, or so on. So that gives me a little bit of feedback on where I'm at. So that's what this first task is, task blink. Basically a while loop, and this is running parallel right next to the task main. The loops is set to 0, while the count, and that count is a global variable, so it's used by both tasks. While the count is greater than the number of loops, it will continue to blink on and off. When it hits that number, it pauses. I have a little wait for a second, and then it blinks the 3 times, waits a second, and then blinks the number of counts again. So that's running kind of alongside the other one. Task main, well, I had to start the first task with that start task blink command, and then end motor encoder is the name of that encoder that's actually hooked or integrated into the 269 motor, which is my winder motor. Alright, so I've set that equal to 0 so that the count starts at 0, and then my while loop begins. And there's just a bunch of parallel if statements taking place. If the sensor, and this is my bump commands or my counts are happening here, if that is set to 1, it's going to start to add count to the 0. I had to come up with a 0.5 was my system, because if I didn't have the weight 0.5, that thing ran through that if command and it went up to 1,000 counts pretty quickly. So I had to create a 0.5 to give myself time to get my finger off of the button and back onto the button again. And then the limit switch basically counts the opposite direction, but they're both affecting that same variable. My control knob in the wind up position basically is this is my equation right here that I got doing the y equals mx plus b formula that we were doing yesterday with 4 times my control knob sensor divided by, or my potentiometer divided by 189, subtract 26 from that is kind of how I came up with the motor speed. And then that will stop the motor if that reaches it, resets my count, and it resets my encoder at that time. So I can continue to add and subtract the line. Alright. If that's not happening, that means it's going in the other direction. So I had to come up with the formula for it to go in the opposite direction. Slightly different numbers, but doing the same thing going in reverse. And if neither of those ranges are met, it stops the motor. So that's where it is in the middle. So it was, I don't know, I thought it was pretty complicated to stack all those things together. So right now I'm at count 4. It's blinking 4 times. If I rotate this thing in the wind up position, if I go fast or slow down, and then when it reaches the 4 count, it resets. So I can set a value to 1, 2, 3. I can go the other direction, and it will lower it 3 inches going the other direction. So I can continue to either wind up or drop down those given amounts.